Hello, Statistics student. This video is for chapter 1.3. We're continuing with the discussion on grouped frequency distribution table that can be used to summarize a set of quantitative data into classes. Before we do that, in the last video we talked about from the grouped frequency distribution table. There are two types of additional frequency table that we can do. One is constructing relative frequency. That means find percentage of that particular class, each classes, and also cumulative frequency that talks about how many frequency there are that's less than a number. And this less than number usually is a lower limit. Of course, that no one is less than 75, so we don't have to specify that. The first one would be less than 125, the second class. So everything in the first class is less than the second class lower limit. So we get 11. And then you just keep on adding them. So for less than, so last time we didn't finish this. So the second is less than 175. So the third one will be less than what? All of these three classes are less than 225, right? So you say less than 225. How many are those? It will be 11, 24, and 10, because these are all less than 225. So I add 11 and 24 and 10, so that would be 35 plus 10 is 45, right? And then what is the next one? The next one would be all of them are less than 275. It's still less than. So for the classes of a cumulative, so these are called cumulative frequency. The classes are not some one to the other, from a lower to the upper, but always less than a number. Less than 325 would be, no, less than 275 would be the first four. So this is, if this is 45, so add 3 more, it will be 48. And then the last class would be all less than what? All less than one more than the last one. So all of them should be less than. The last one is 324. So all of the number are less than 325, right? So you just add one more, and that would be all numbers, which is 50. So this is called cumulative frequency. It can answer question of less than a number. Sometimes you might run into a frequency table like below. Because there's no industrial standard on how to create frequency distribution, occasionally you will see frequency table like this, 2.95 to 4.97. And then the second one is 4.97 to 6.99. You might wonder, Ms. Chan, if I have a number of 4.97, should it belong to the first or the second? Now, usually when they pick a class limit like this, there is no what is it called? There is no chance of having a data that is 4.97. Usually the real data is actually two places. So the highest number would be 4.9 or 5.0. But in case you really want to find out if it is 4.97 or 7, what is it supposed to be? The common convention. Okay, so common convention is if they overlap, they seems to be overlapping, is the first class would not take 4.97. The first class will not take 4.97. 4.97 will belong to the second one. So that means whenever you have a class that overlap, it's the inequality would be any data that is equal to the lower limit would belong to it, but just always less than the upper limit. But very often you would not have data that is two places. They arrange it in such a way that all the data would only be one places, so they are either 4.9 or 5.0, so everybody knows which class it belongs to. So let's use this and find out what percentage of town with a rainfall less than 9.01. Now 9.01 is here, right? So everyone that is less than 5.01 should be the first three, right? Because 5.01, if there's a rainfall of 9.01, it should belong to the fourth class. So the frequency that is less than 9.01 would be all three. You will see that if I have a cumulative frequency table, I would be able to do that. Okay, I would look at less than 9.01, I would have a cumulative frequency here. Where you see how if you have a cumulative frequency is very helpful for you. So in this case, I don't, so I would just do 6 plus 7 plus 15, and that's 28, right? But they ask for percentage, so I need a total. So why don't I do a total here? How many rainfall did we collect? 6 plus 7 plus 15 plus 8 plus 9 plus 5. That is 50. Oh, they're a good number. So the percentage would be, in terms of percentage, would be 28 over 50. And that is 56%. If you use a calculator, that's exactly 56%. So sometimes you would use these frequency table to answer questions like this. So maybe if it's less than 9.01, that time is classified as, drought or something. You would want to find out in how many months they have drought, something like that. Sometimes you have frequency table where the classes are actually years. So it records the number of clashes, but then this is still a frequency table. Number of clashes is a count, but they are corresponding to years. So we still call them as frequency table, but let's find out what they're asking. 5% of crashes occur after 2015. So after 2015 would be what? From 2016 onward, right? So I will add all these number together. So in my calculator, I will add 378006 plus 37473 plus 36560. So all this number of crashes would be 111839. But to find percentage, I want the total, right? So I have added these three together, so I'm just going to add on the rest of them. Add 35485. Is it an 8? Yeah. Plus 32744 plus 30203. So now the total is 210271. Okay, so what percentage would be? To do that, I would do 111839 over the total 210271, change into percentage. So in my calculator, I'll just copy that number divided by the total number, and that is equal to 0.53188, blah blah blah. But in percentage, there will be 53 point. I want one places, so I round up 0.2%. Okay, so the last 3 years correspond to 53.2% of the total clash of the 6 years. So it seems like this is more than half. So you can tell that this is more than half of the 6 years. So the next things we want to do is actually how do I construct a grouped frequency table from data? If I have data, how do I construct it? So far, we have been using them to find percentage. We use a table to analyze data, but how do I do it? Here, instead of using Statistic can actually do it, but I want to talk about it when we do histogram in chapter 2. So if you are just interested in making it like a table, there's so many different ways. The very straightforward way is to use a calculator called social science statistic calculator. This is not the calculator that we use most often. We would be using most often something called a Statistic, which can do the same thing, but I'm going to wait until later. We are going to use a calculator called social science statistic calculator. So you click on social science statistics, so it has descriptive statistics, and then frequency distribution calculator. The one thing that I don't like this calculator, there's a lot of ads So that's why. They can do a lot of stuff, but I think this is a little better. Less, that's no ads, so that you can see that there's so many ads over here. So where's my data? So I'm gonna just run an example. Now, these things I just want you to do, so to have an experience of doing it. I'm not testing this, so you don't have to worry that, oh, how do I have to practice doing this? You don't need to. When you do the project later on, you will be doing this using Google Sheets or Excel. Actually, after you learn how to the graph the data instead of table, it is not very important. So, but I just for formality, I show you how to do it. So this is your data, commute time. I put them in Excel, so it has a list of data. Okay, I don't want the label, so I'm going to highlight the data only, except the label. So do not want the label. So do a copy, paste only the data. And then you would want to go to frequency distribution calculator and paste it. So this would be a list of data, or you can enter it one by one. Okay, enter them one by one, like in a column, and then you click generate. So when you do generate, it will generate a frequency distribution. Count means frequency, and they would, randomly pick some ranges for you. In this case, they pick 20 to 33, 34 to 47, but there is only 5 classes. So if you want more classes, you would go down and here, edit frequency table. You would say, I want 7. Okay. And you can also adjust your lowest class limit. In this case, you just take whatever that they want to give you. I think the lowest is 22. So you do not want to start from a very odd number. 20 is a good number. So just take it. You can also specify class range you want to. They will tally for you. But very often you just want to increase your classes so you have more granularity. So then after this, I think you do edit frequency table, is it? Yes. Then it would generate a new one. So this would be, you can see that it's, you have more classes, 1, 2, 3, 4, 5, 6, 7. And they will count it again for you, and they actually would do the percentage for you in a total. So this would be your answer if you want to have like a frequency distribution calculator to count those in different classes for you. But again, I'm not going to test it because later on we will learn how to do it with histogram. And you can use Statistic to do the same thing. So here I cut and paste the frequency distribution table here. Okay, so that is all of chapter 1.3. 1.3 we learn how to, I think in this particular section, the main thing is how to understand what a frequency distribution is, what is cumulative frequency, what is relative frequency. Making a table is not super important, but you should know the terms. Okay, you should know what is a class limit, what is a class midpoint. Those are important.